So let's review the calculation here one more time. Generally, we have Q, the heat, that's equal to the W, that's the energy equivalent of a calorimeter, W, times delta T. So there is no mass term in here. W equal to C times M. Okay, so no mass here. And that equal to the heat of combustion of a benzoic acid times the mass of a benzoic acid, plus we have a corrections of a nitrogen, sulfur, and a fuse. So we use benzoic acid to calculate the W, right? In this case, every term here is known or can be calculated, and we measure delta T, and we need to calculate the W. So that's for benzoic ROMs. Basically, W equal to H, that's benzoic acid times the mass of a benzoic acid plus corrections divided by delta T. We also have a tape rounds, which is to calculate the tape corrections. H tape, so H is here. So the H tape will show up in this equation, the W times delta T equal to H tape times the mass of the tape. So in this case, we need to make the mass significant. So we will put a lot of tape all together into the cup to make the measurement in that case, in the tape rounds, okay? Measure the mass of the tape, and we know the corrections. The corrections, still the nitrogen corrections, the fuse corrections, and the 0 for sulfur. So in this one, we use this equation because we already calculated W, and the only thing unknown will be the H tape. So in this equation, we need to figure out the H tape. After that, we can measure TTCC and the cyclohexene. In this case, we will do exactly the same thing for tape. So we need to calculate the HTTCC, the heat of a combustion of TTCC here. We still use the same equation, W delta T equal to heat of a combustion of TTCC times mass of TTCC plus other corrections, that's nitrogen, sulfur, and fuse, and then plus the tape corrections. We can use the H tape we calculated in this step and use the mass of the tape that's measured in each TTCC ROMs. Does that make sense? So the mass of the tape should be much lower, in this case, should be much lower than the tape rounds, because we just use a little tape to cover the burning cap. Okay, so this small amount of tape, and this is a lot more than this case. Okay, and for cyclohexene, it will be just the same as the TTCC. On Canvas, we'll have this presentation slides, and there are experiment instructions. There are bond calorimeter operating instructions. And this one, the second one, is green binder handout that includes all the calculation you will see, you will use in your experiment. And the equation 3-1, 3-2, and 3-15 are in this handout, okay? And the bond calorimeter standardization PDF, that is the calibration, that's how you run the benzoic acid runs, and the bond calorimeter calculations, and the bond calorimetry volatile sample instructions, so that which is to use the tape. And there is a video showing how the lab is done. There are experiment data That's a partially formatted data that's in the spreadsheet. And this is a notebook data. You'll find that the weight of each measurement. And I also provide a partial writing example. So it's not as the previous experiment. I provide you a full writing example. So this one will be partial, and you can use this one as a reference, and you can use the literature as reference. Remember, I asked you guys to look up the resonance energy of a benzene in literatures, and you can find that literature, and you can use that as a writing example. You need to calculate the resonance energy of a benzene by the data provided. Also calculate the uncertainty values, compare that value with the literature, and discuss your result and write a full lab report. There are some writing tips for this one. Be concise. So read the reference article provided on Canvas before you start putting it together. So you can know what's need to be in the lab report, because there are so much data in this case. We don't need every single data runs in the body of the lab report. You can include the most of the data runs in the appendix, but not all in the body of a report, okay? So try to be concise of your report. And in your introduction part, a lot of students would focus on the calorimeter or calorimetry instead of resonance energy of a benzene, okay? Remember, the purpose of this experiment is to indirectly measure the resonance energy of a benzene. The purpose of this experiment is not calorimetry, okay? So focus on resonance energy of benzene. Do not spend a lot of time writing about calorimetry. Experiment, pay attention to what type of fuse was used, okay, compared to the experiment handout. In the experiment handout, you will see the iron fuse is used. And in our case, we use cotton fuse, okay? Pay attention to those details. In the results section, again, do not include all data. Be concise. So if you have a literature article, read it, and you'll see you don't need to put everything you have done, you have analyzed in your results section. You can put the most of them in appendix. Sample calculation, make sure you include the uncertainty calculations, okay? So if you are, you did multiple rounds, remember you did multiple rounds in TTCC and cyclohexane, and how do you calculate uncertainty of the delta H of TTCC? If you did that 3 times, right, you measure it 3 times, there is no partial derivative need to get involved in this case. You measure that 3 times, and you will use the value of each time to calculate the average and also calculate the estimated standard deviation, okay? And please review the last slide of the aerial analysis. Using the last slide of the aerial analysis, we show a case that you can do multiple rounds, and then you figure out the average and the uncertainty.